Hi, and welcome to my talk titled Security Best Practices Protecting Against Common Vulnerabilities. My name is Ukanah. I'm a full stack web developer, security researcher. You connect with me on LinkedIn. I currently work as a backend developer at Standard Technologies and a full stack web developer as a freelancer. And yeah, so let's delve into the talk. So we'll be covering introduction to Python security, common security threats in Python, secure coding practices in Python, authentication and authorization, hashing and encryption in Python, encryption and hashing, Python security tools and libraries, emerging threats and feature consideration, and finally our conclusion. So let's get right into it. Section 1. Introduction of Python security. An overview of Python's popularity and relevance in software development. Python was officially released on the 20th of February 1991 by Python Software Foundation under the direction of Guido van Rossum. It has grown a considerable height over the years up to now. In our current time, Python ranks at number one in the PYPL index. That's the popularity of programming languages index. So we can see in the chart how Python was from 2005 up to number one in 2024. So yeah, being utilized in the development community among both engineering and computing teams, also in the artificial intelligence sector at large. This provides the efficiency of Python as a reliable development slash programming language. Python is also known to be used in large scale enterprises, some of which are listed below. So Python is used in Netflix, Google, Reddit, Spotify, Instagram, Dropbox. These are just a few of the numerous companies that make use of Python. And the importance of security in Python based application. Security in Python web applications and applications in general has become a top priority and a crucial aspect to consider during development. Many Unix systems come with Python pre-installed, making them potentially vulnerable to Python scripting attacks. If a Python application running a compromised Unix-based system lacks proper system measures, it's highly susceptible of to attacks that could lead to the theft or leakage of sensitive information. On June 5th, 2012, popular social network website LinkedIn was hacked. In this popular hack, the passwords were of over 6.5 million user accounts were stolen. Internet security experts said that the passwords were easy to unscramble because of LinkedIn's failure to use a salt when hashing them. We will cover that in secure coding practices when we go over to section 3. The passwords were gotten as a result of an SQL injection attack. The attackers exploited a vulnerability in a third-party library used in LinkedIn to inject a malicious SQL code, granted them to a vast amount of user data. LinkedIn apologized immediately and asked to change the password, which seems like a very efficient response to the situation. Probably after fixing the bug, most likely. C. A brief on the article's purpose and structure. This presentation aims to provide a clear and detailed insight to the essential security best practices in Python web applications and general Python development. We will delve into the following areas: the common vulnerabilities and threats specific to Python applications. We cover topics like SQL injection, cross-site scripting, cross-site request forgery, secure coding practices in Python. We will handle input validation and sanitization, proper use of libraries and dependencies, secure file handling, avoiding common pitfalls. That is, learn how to avoid common security mistakes that can lead to SQLIs and XSS. From there, we'll proceed to authentication and authorization method, the best practices implementing secure authorization schemes. We will then give a noteworthy coverage on encryption and hashing in Python. So let's delve into these topics. Section 2. Common security threats in Python. An overview of common vulnerabilities and threats specific to Python applications. We recognize that modern applications are inherently susceptible to security flaws. Some of these flaws are inherent to the technology stack, while others are common pitfalls in programming projects. Regardless of the source, virtually all applications built with any programming language will inevitably have security vulnerabilities. Therefore, it falls on developers like ourselves to identify and address these vulnerabilities before malicious actors exploit them. Let's start with the first one: SQL injections. SQL injection, SQLIs, is a common and dangerous web security vulnerability that arises when malicious SQL code is injected into an application's input and subsequently sent to a database. This allows attackers to manipulate the internet SQL queries, potentially granting them unauthorized access to information or even control over the database itself. SQL injection can have devastating consequences, potentially leading to data theft. Attackers can steal sensitive information like usernames, passwords, credit card information, and more. Data manipulation. They can modify or delete data, impacting website functionalities or causing financial losses. System takeover. In extreme cases, they might even gain full control of database server. The next one is cross-site scripting, XSS. Cross-site scripting is a web security vulnerability that allows attackers to inject malicious scripts into websites. These scripts are then executed by unsuspecting users on the browsers, potentially leading to data theft. Attackers can steal sensitive information like cookies, session IDs, and other data stored in the browser. Account takeover. They can hijack user accounts by capturing login credentials or manipulating session data. The next one, website defacement. They can alter website content or redirect users to malicious websites, which is really, really dangerous. Spreading malware. They can inject malicious code into other websites visited by the user. Cross-site request forgery, CSRF. Cross-site request forgery, also known as CSRF, is an attack that forces an end user to execute unwanted actions on a web application in which they are currently authenticated. They can have significant consequences like unauthorized transaction, data theft, website defacement. The last one we cover is command injection. Command injection is a less popular injection attack compared to SQL injection attacks. This is because orchestrating such an attack takes time and concentration. However, overlooking command injection attacks can leave your system or application vulnerable to some big threats, and in some cases, could lead to full system compromise. Command injection sends malicious data into an application that can lead to grave damage when evaluated by the code interpreter. Simply put, this is when an attacker is able to execute commands on your application server via a loophole in your application code. This we could also call this remote code execution. Data theft. This could lead to data theft. Attackers can access sensitive information stored on the server's file system, database, and other systems. System takeover. They can gain control of the server, allowing them to install malware, delete files, or disrupt operations. Lateral movement. They can use this compromised server as launching point to attack other systems on the network. Some other notable mentions includes attackers can also leverage on misconfiguration in our Python application, such as insecure file handling, insecure authentication, and insecure direct object references. Next next subsection says examples of past security incidents in Python-based application. In Dropbox in 2012, a large-scale phishing attack compromised over 68 million user accounts, potentially leading exposing potentially exposing email addresses, names, and passwords, hashed but not sorted. Reddit in 2018. A data breach affected over 50 million user accounts, including usernames, email addresses, and passwords, hashed with SHA-1, considered weak at that time. That was 2018. Yahoo in 2014. A series of data breaches compromised over 1 billion user accounts, exposing various personal information, including names, email addresses, phone numbers, and even birth dates. Then the next section says, understanding the risks why Python applications are targeted. Python popularity and ease of use makes it a target for attackers due to several inherent environmental factors. This report explores the key risks associated with Python web applications. Key vulnerabilities, input validation and sanitization. Inadequate input handling can lead to SQL injection, XSS, and command injection. Third-party libraries. Vulnerable libraries introduce known security risks into application. Framework-specific vulnerabilities. Each framework has unique security considerations that require attention. Pre-installed Python on Unix. Pre-installation can be convenient, but requires consistent updates to address vulnerabilities. Then we have system permissions. Improper permissions can grant unauthorized access to sensitive files and directories. We are going to the next section, which is section 3, secure coding practices in Python. We start with input validation and sanitization. The front line defense against injections. That's what I like to call it. Input validation is the process of ensuring data entered by a user is valid and safe before it's being processed by the application. This is a crucial step in ensuring our Python application in securing a Python application against common vulnerabilities such as SQL injections and cross-site scripting. Part of data validation which should be considered involves the following step: trimming of data inputs, regular expression and form input validation, enforcing the use of secure passwords, numeric range validation, drop menu selection, and file upload validation. Let's start with trimming of data inputs. This simply involves removing leading or trailing spaces from user input fields like names or addresses. Trimming ensures consistency and avoids unintentional white space in data storage or processing. This makes sure to utilize string functions like trim in Python or dedicated trimming libraries. Regular expression, regex as we usually call it, and form input validation. Validating input text and email addresses to ensure they follow the standard custom formats using regex patterns. Regex helps enforce specific constraints on data formats, preventing invalid entries like missing at symbols or incorrect domain names. Libraries such as RE in Python offer regex for functionalities. Also, validation packages like Django Forms also support regex-based validation. Enforcing the use of secure passwords, checking password length, character types, that is the uppercase, lowercase, numbers, symbols, and disallowing common dictionary words. Strong password policies prevent weak and easily guessable passwords, mitigating unauthorized access risks. Libraries like parslib in Python can generate and hash passwords securely. Django uses bcrypt, an industry standard algorithm known for its high computational cost and resistance to brute force attack. Drop menu selection. This is also a good option to consider as it limits the selectable options to an application predefined list. This way, invalid or unsafe responses cannot be imputed as values. File upload validation. This is a very important step as invalid file uploads have been known to create backdoor access or lead to reverse shell instances. Ensure to validate files on the server side and never rely on client-side validation alone. Always maintain updated versions of file validation methods and libraries to ensure potential vulnerabilities to address potential vulnerabilities. Here are some detailed considerations to take. Number one, file type validation. Ensure implement measures to check the file MIME type to ensure it matches allowed types. That is image slash JPEG, application slash PDF, all of that format. Consider utilizing the Django's file content type property. Check the file extension against wide list of permitted extensions such as JPEG, PDF, and using the file ext property. In number two, file size validation. Set a maximum file size allowed for upload using max upload size setting. Implement logic to restrict the total combined size of uploaded files per user or session. These are efficient and effective to ensuring proper and safe file upload. These are very good practices. Malicious content detection. Leverage on antivirus libraries and or APIs to scan uploaded files for malicious content. Make use of Pillow to validate the image integrity and upload potential vulnerabilities and prevent potential vulnerabilities like cross-site scripting attacks. Temporary storage. Consider using temporary storage locations for uploaded files before final processing and validation. The next one, we have proper use of libraries and dependencies. It is important to ensure proper use of libraries and dependencies in our Python application to help manage code lifecycle, dependencies, and outdated library vulnerabilities. When it comes to proper management of libraries and dependencies in Python development, it is necessary to state that the use of poetry is a first-class solution worth mentioning and looking into. Poetry is a tool for dependency management and packaging in Python. Poetry basically allows you to declare the libraries your project depends on, and it will manage them for you. It is worth mentioning that poetry can also build your project for distribution. The next subsection goes handling sensitive data. Most of the time, sensitive data includes data designed by a business to be labeled as sensitive. This could be personal information, file data, or information generated by a user while on an application. There are also information which should be generally considered as sensitive data, such as financial information. We can say that sensitive data is in sensitive data is any data that an attacker values the most. That is definitely sensitive data. So you want to keep that data away from the attacker. To create methods to securely handle sensitive data, we think about what matters the most to application and to our users, focusing on the centralization of this data and its security. We can as well leverage on platforms that offer authorization as a service, platforms like permit.io and piano.com. Steps to follow when implementing methods to handle sensitive data. We can follow encryption, authentication, sanitization, logging, and testing. All these steps help in when it comes to handling sensitive data. Then we go to the last section, the D section, which says secure file handling. When it comes to handling files in Python application, there are there are following important actions to carry out. Let's talk about some of them below. Number one, in, input validation and sanitization. Start by validating file names, restrict allowed characters, and remove potentially harmful elements to prevent path traversal attacks or code injection. Since sanitize file content. Depending on the context, consider techniques like antivirus scanning, integrity checks, or content parsing for malicious code before processing. Validate file types and extension. Use whitelist to accept only permitted file types, that's JPEG or PDFs, and prevent unauthorized uploads that might introduce vulnerabilities. Number two, secure storage. Store files in secure locations. Employ appropriate permissions and access control mechanisms. That is, change mode, change ownership to restrict unauthorized access. Consider temporary storage. Use temporary directories or processing uploaded files before moving them to permanent storage locations, minimizing potential damage in case of vulnerabilities. Encrypt sensitive data. In files, if files contain sensitive information, encrypt them at rest using libraries like Fernet and then decrypt them only when necessary. Code level best practices. Use context managers. The first one says use context managers. Utilize context managers such as like to bit open for opening files to ensure proper file closing and resource management, preventing potential vulnerabilities like leaving files open for unauthorized access. Avoid hard-coded paths. Very important. Dynamically construct file paths based on user input or other variables. Certain static paths might be exploitable. Utilize secure libraries. Employ well-maintained and secure libraries for specific file handling tasks, e.g., OS for basic file operations and Pillow for image manipulation. Regularly update dependencies. Keep your Python interpreter, libraries, and frameworks updated to ensure to address potential security vulnerabilities. The next section, which says authentication and authorization. The first subsection states best practices for user authentication. In developing user authentication, user authentication in Python application, here are some best practices to be mindful of and utilize when possible. Number one, secure password management. A. Strong password policies. B. Secure hashing. C. Salt generation. D. Multi-factor authentication. MFA. Number two, secure session management. A. HTTPS. Enforce HTTPS for all communication to prevent interception of login credentials and other sensitive data. B. Secure session tokens. Use secure and unique session tokens instead of relying on cookies alone. C. Session timeouts. Use appropriate session timeouts to automatically log out inactive users, minimizing the risk of unauthorized access. D. Secure token storage. Store session tokens securely on the server side, never in client-side storage. Number three, input validation and sanitization. A. Validate and sanitize all user inputs. That is, prevent SQL injection, cross-site scripting, and other attacks by carefully validating and sanitizing all user input, especially login credentials and search queries. B. Rate limiting. Implement rate limiting to prevent brute force attacks and denial of service attempts. These are all worth mentioning. Number four, secure coding practices. A. Avoid hard-coded credentials. Never store sensitive information like passwords or API keys directly on your code. Use environment variables or secure configuration files instead. B. Use secure libraries and frameworks. Utilize well-maintained and secure libraries like Flask login or the Django authentication system for user authentication functionalities. C. Stay updated. Keep your Python interpreter libraries and frameworks updated to address potential security vulnerabilities. Number five, additional considerations. A. Use secure password reset mechanisms. Allow users to reset their password safely through email verification or other secure methods. B. Log all authentication attempts. Log login attempts, including successful and failed ones, for security monitoring and forensic analysis. C. Perform regular security audits. Conduct regular security audits of your application to identify and address potential vulnerabilities in your user authentication system. The next subsection says implementing secure authorization methods. Building fortresses. Implementing secure authorization mechanisms. I put it like kind of team kind of thing. So we have securing your web application goes beyond strong authentication. It requires robust authorization mechanisms to control access and protect sensitive data. Here is a roadmap to guide your implementation. Number one, HTTPS, the essential shield. Encrypt all communication between users and applications using HTTPS. This prevents eavesdropping and ensures data integrity, safeguarding login credentials and user and other sensitive information. Number two, strong authentication, the gatekeeper. Choose a robust authentication method, ideally multi-factor, multi-factor, to verify user identities effectively. Don't settle for weak passwords. Enforce complexity and regularly require password updates. Number three, authorization, defining access rules. Implement a granular authorization mechanism that defines who can access what. Utilize role-based access control (RBAC) or regular modules to assign permissions based on user roles and attributes. Session management, vigilance, guidance. Protect session management. Use secure tokens, enforce timeout for inactive sessions, and ensure proper storage on the server side, never in client-side storage. Number five, secure coding. Build with caution. Follow secure coding practices. Avoid hard-coded credentials. Rigorously validate and sanitize user inputs and leverage well-maintained security libraries. Remember, a single vulnerability can breach your entire defense. Updates and monitoring. Number six, updates and monitoring. Internal vigilance. Keep your web application, frameworks, and dependencies updated to patch vulnerabilities promptly. Conduct regular security audits and monitor application activity for suspicious behavior. Proactive defense is key. By implementing these steps, you build secure authorization mechanisms that protect your web application from unauthorized access, data breaches, and other threats. Remember, security is an ongoing journey, not a destination. Stay vigilant and adapt your defenses as the landscape evolves. Number four, encryption and hashing in Python. Over an overview of encryption and hashing techniques. In the digital world, protecting data is paramount. Two key techniques used for this purpose are encryption and hashing. While both transform data, they serve distinct purposes. Number one, encryption. Reversible. Number one, encryption. Encryption is reversible. Encrypted data can be decrypted back to its original form using a secret key. B. Confidentiality. It protects data confidentiality by making it unreadable to anyone without the key. C. Common uses. Secure communication, HTTPS. Storing sensitive data on disks, protecting files in transit. Popular algorithms involve AES, RSA, CHA 20. The next one is hashing. Hashing is a one way. It transforms data into a unique fixed length string called a hash. B. Integrity. It ensures data hasn't been tampered with. Any change in the data will result in different hash. C. Common uses. Password storage, hashed, not stored in plain text. Verifying file integrity, digital signatures. The popular algorithms involve SHA-256, SHA-2512, SHA-3, and Bcrypt. Bcrypt is one of my personal favorites. And the key differences in purpose, encryption focuses on confidentiality, while hashing focuses on data integrity. Reversibility, encrypted data can be decrypted, while hash data cannot be reversed. Computational cost. Hashing is generally faster than encryption. Choosing the right technique. The choice between encryption and hashing depends on your specific needs. You need to access original data, use encryption. Want need to verify data integrity, use hashing. Want to combine both, use sorting with hashing for password storage. That is, add random string to the password before hashing, making it even harder to crack. Remember, both encryption and hashing are essential tools for data security. Choose the right technique based on your specific needs. Keep your eyes on algorithm secure. Now, implementing encryption and hashing in Python application. So let's go to code sample we have. So in this code sample, I would quickly change to my okay. So let's first of all we have our Python environments created. Um, confirm. Let's change to our Python environment. PIP freeze to check while it's doing that. Let me create an encryption .py. This is where we test our encryption and we'll have our hashing.py. So let's quickly install our hash keep. Let's quickly install Bcrypt first. Let's also install cryptography. These are important. So let's start with encryption. That is installed. So we can get cryptography. This is our module unit import. So let's start first of all by creating our cipher key used for the encryption. So variant dot generate is generate the key. Then we have our let's say our cipher suite. This takes in our key, the cipher key which I've created here. Now let's encrypt our message. So let's create a message. We'll set this message in bytes. This is a confidential text received from NSA. Ooh, encrypted encrypt. So this way we encrypt our message. Now let's decrypt this same message. Decrypt our message. Decrypted message. So we'll still call our cipher suit the decrypt or passing our encrypted message. So in this case, we'll print our original message. Yes. So here we print encrypted message, encrypted message. Have encrypted message here and decrypted message here. And for this, we shall have to do dot decode to get it to print. Let's not forget to save the file. Oh, where is that error coming from? Yeah. So now let's quickly run our code Python. Yeah. So this is the confidential text from the NSA original message. Then we encrypted it. This is the encryption, encrypted text, and then we decrypted the text again. See, so it works very well. This is a very good method to utilize in our Python applications or Python projects. In case you find yourself working with a framework that doesn't you don't understand the let's say you don't understand the encryption method or the hashing method. So you want to use your own. You can easily use this method, which has been shown here, to encrypt your information, and you can make it much more difficult depending on what you want to do with it. So now let's work on the hashing. So to get our hashing working, we import hashlib. Let's import recrypt. Let's also import random. Now let's get our data to hash. Let's say say this. Let's make it a byte data. This is data from my father. Now let's hash this sh256. Apologies, just using the shift button down there. So we call it the sh256 hash because in this case we want to hash it using the sh256 algorithm. We will call hashlib. I will do sh256 and we'll pass our data in here. We will simply then say exit or digest, text digest as to convert it. So this is our hash data, which we'll print very soon. Now let's hash with SHA256, this time with salt. So this basically makes our code hash data much more difficult to crack. Yeah. So in this case, we created some random bits. Let's give it 256 value there. Now sh256 hash with let's call it with salt. Let me say sh256 live dot sh256 data. And here we'll simply just convert this to bytes, this also to bytes. This is currently in a string format and we have our data in a string format. So let's in a byte format. So let's convert this to bytes, etf8, and simply text digest. Now that is for this is using the hash lib to hash. So now let's make use of let's hash with bcrypt. Now I mentioned that Buckets is my personal favorite because even in the Django, and when I'm working my Node applications, I still make sure to use Bcrypt because it really makes your passwords really complex. Gives that complex feeling. So let's work with Bcrypt hash because Bcrypt dot hash pw most like a password. Uh, pass our data and let's pass Bcrypt dot gen salt. That's generate a salt. So you can actually add your own custom values there, but let's just use the default one provided by Bcrypt. So let's call this SHA-256 hash. Then we'll have this as SHA-256 hash. And I'll simply create a new line for this. And let me duplicate that. And this is SHA-256 result. This is Bcrypt hash. Call this Bcrypt Bcrypt hash with salt. Save this and let's run our code. Let's Python. Yeah. So as you can see, the Bcrypt looks a lot more complicated. We're having full stops, we're having dollar signs, we're having slash. On the other hand, our SHA is just our SHA-256 is just numerals, and I don't think I even see capital letters here. It's just a bunch of small letters and numbers. The first one is just numbers. The second one is just still numbers and letters though. But we get the point. So these are very good methods that we can use for creating hashing and encryption of our messages, text, whatever information we want to secure. I hope that was um, a good example for you and you really understood that. So now um, let's come back to our talk. So I've gone through implementing encryption and hashing in Python application. Let's now go to best practices for secure storage of password and sensitive information. Protecting sensitive information, especially password, is crucial for any application. Here are some practices. Number one, never store passwords in plain text. Never do that. Use secure hashing with salting, just like I showed you. So verify passwords securely, store hashes and salt securely. Utilize environment variables or secure configuration files to store hashes and salt, not directly on your code. Consider utilizing password management systems for additional security. There are other libraries you can leverage on for that. Use secure frameworks and libraries. The Django and Flask offer built-in passwords hashing mechanisms. Utilize libraries like Parsley for password advanced password hashing features. Then the last one, encrypt sensitive data. For data beyond passwords, consider encryption libraries like Fernet or cryptography for secure storage and transmission. So number five, we have Python security tools and libraries. So number one, here we have introduction. Our first subsection, we have introduction to security focused libraries in Python. So in the ever evolving security landscape, Python developers have access to rich ecosystem of libraries that empower secure coding practices. This note delves into the strength and use case of several prominent libraries, offering guidance on how they can enhance the security of your Python application. So number one, we have cryptography. Core features include versatility, cryptography operations, including symmetric encryption, ESA, SHA-20, asymmetric encryption, RSA, ECC. Hashing also SHA-256 and Bcrypt. Message authentication codes. We have HMAC and digital authentic signatures. The next one we have security use cases. Securely store and transmit sensitive data, implement user authentication and authorization mechanisms, digitally sign and verify files to ensure integrity, securely communicate over networks using TLS, and SSL. That's transport layer security and secure socket layer. So we have Nmap. Core features include network discovery, scanning, including port scans, OS detection, service identification, vulnerability detection, limited, okay, and packet sniffing. So security use case here is identify potential security vulnerabilities in your network infrastructure, enumerate services running on remote hosts to access potential attack vendors, gather network intelligence for penetration testing and security assessment. Then number two, we have Scapy. Core features include network packet manipulation, crafting, sniffing, and analysis, supporting various network layers and protocols, TCP, IP, Internet. Security use case. Develop and test custom network security tools for intrusion detection, penetration testing, network forensics. It also involves analyzing network traffic to identify suspicious activity or protocol deviation, crafting custom network packets, vulnerability testing, and network force. Number four, we have core features. Number four, we have in packets. Packets is a package that I really care about. The core features include interact with network protocols like SMB, file sharing, RPC, DEP, DCE/RPC, and Active Directory, primarily used for Windows systems. Security use case includes automate penetration testing and vulnerability assessment in Windows environment. Um, Perform credentialed attacks and post exploitation activities after gaining initial access, extract information from network shares and Active Directory from security analysis. So, analysis and demonstration of security tools and yeah, integration of usage examples within. I'll cover this integration and usage of user examples within Python projects. So I'll cover this while we have done almost done with the most of the topic talk. So number section six, emerging threats and feature consideration. Okay, as we are coming closer to the end of it, what are some emerging threats and feature consideration? Anticipating and mitigating emerging threats. So a rapid evolution in technology and the ever-growing attack surface make anticipating and mitigating emerging threats crucial for any Python developer. This article here explores key strategies to stay ahead of the curve and ensure robust security in your project. Number one involves identifying potential threats. Next, then under the sublist include staying informed. Regularly follow security news and updates on vulnerabilities in fact affecting Python libraries, frameworks, and dependencies. Subscribe to security advisories and mailing lists of prominent Python project. Another thing to do is to join Python communities. We have them on Discord, Slack, all around. I think also on Twitter we can find Python communities here. So join and get engaged. Understand attack vectors. Familiarize yourself with common attack vectors, targeting Python applications such as SQL injection, XSS code injection, and vulnerabilities in external libraries. Proactive threat modeling. Okay, so conduct threat modeling exercises of your for your application to identify potential attack surfaces and vulnerabilities early in the development process. Mitigating risk. That's number two. Secure. How do you mitigate risk now? Secure coding practices. Fully established secure coding practices like input validation, output encoding, proper error handling, secure password management. Use libraries like cryptography for encryption and passlib for password hashing. Next one, dependency management. Use secure and well-maintained libraries and frameworks. Regularly update your dependencies to patch known vulnerabilities. Utilize tools like pip, pip the tree, pip depth tree for dependencies visualization and vulnerability analysis. Okay, we also have secure configuration. Ensure the application configuration is secure, avoiding exposure of sensitive information. Use environment variables for storing secrets instead of hard coding them in code. Continuous monitoring. implementing logging and monitoring systems to detect suspicious activity and potential incidents. Tools like ALK stack or Gradlog can be helpful to centralize log management and analysis. Penetration testing. Conduct regular penetration testing of your application to identify and address exploitable vulnerabilities. Utilize tools like Metasploit, Kali Linux for penetration testing exercises. Always make sure to do things like this with a team, so that you don't just be working alone and you get point of views from other people in case you're missing something. Staying ahead of the curve. That's number three. Staying agile and adaptable. Being prepared to adapt your security practices based on the latest threats and vulnerabilities. Emerging threats are constantly evolving, so continuous learning and adaptation are key. The next one says leverage community resources, like I mentioned earlier. Participate in community security, in Python security community. Utilize forum, mailing lists, and security conferences to stay informed. Share knowledge and learn from others' experience. The last one says embrace security automation. Automate security tasks like dependency scanning, vulnerability patching, and configuration management for improved efficiency and consistency. Remember, security is an ongoing process, not a one-time fix. By adopting these strategies, you can proactively anticipate emerging threats, mitigate risks, and build more secure Python applications, which is the goal. So, some additional tips to mention: consider using secure coding frameworks. Frameworks like the Django, Flask, Pyramid offer built-in security features that can help protect against common vulnerabilities. Number two, educate your team. Make sure to get a team first of all, and encourage your development team to follow secure coding practices and stay up to date on security threats. Utilize cloud services. Following up security threats, a good mailing service that can follow is the Hacker News. It's worth mentioning. So they give quality and top-notch news on the latest data breaches and hacking news generally. So the next one says utilize cloud security services. Cloud platforms like AWS, Azure, and GCP offer various security features that can benefit your Python applications. So B, future lookout for Python security practices and advancement. Here are some key points to consider. Growing security awareness. Okay, so the Python community is increasingly aware of security concerns, leading to a greater focus on secure coding practices, vulnerability management, and threat mitigation strategies. Security focused libraries and frameworks like cryptography, Passlib, and Bandit are seeing wider adoption and development. Take a course on YouTube, take a course on Coursera, anywhere you can find, probably Udemy. There are lots of courses that talk about these frameworks and how they can be used properly. So yeah, just for you to so you know how to utilize them in your Python applications and make more secure and more strategic Python applications. So, educational resources and training programs on Python security are becoming more readily available. So, just for little amount of money, you can get these courses and get certified in them also, and you have the knowledge. Yeah. So, number two states advanced security tools and techniques, static code analysis tools. Continued advancement in tools like Bandit, Flake 8, PY-Lint will enable proactive identification and prevention of security vulnerabilities in code. The next one says AI-powered threat detection. Machine learning and artificial intelligence will play a bigger role in analyzing code, network traffic, and log data to detect and respond to security events in real time. Next one says quantum's resistant um, um, cryptography. As quantum computing evolves, new cryptographic algorithms and libraries will be developed to ensure the security of data and communication. The third one is integration with development workflows. Security will become more seamlessly integrated into development processes with tools and practices embedded in CI/CD, continuous integration, continuous development pipelines, and automated testing frameworks. Security considerations will be woven into all aspects of of the development process, from design and architecture to coding and development. Developers will have access to better documentation, tutorials, and training and navigate security concerns and integrate them effectively. Focus on cloud security. Okay, with this is the last one. It seems with the increasing popularity of cloud-based development and deployments, cloud security solutions specifically designed for Python applications will become more prevalent. Integration of Python security tools with cloud platforms will streamline coding practices and provide virtualization management for security configurations. That's like AWS, GCP, Azure, and DigitalOcean, and the likes of that. So, section 7, summary of key takeaways. So, summary talk. Here I will just basically give you what's on my mind on the summary. So, we've covered a bit of a lot of things. We've talked about we've talked about the best practices, a little best practices, and how to make sure that okay. Let me just briefly come over to uh, so we talked about the introduction to Python security, common security threats in Python, secure coding practices in Python, authentication and authorization, encryption and hashing in Python, which I gave a code sample, Python security tools and libraries, emerging trends and future consideration. So all of these are really important information that with this knowledge and extra practice, you can gradually implement them in your Python application and Python development, and with strict and adherence to some of these best practices and many of these best practices, you can ensure to build more uh, rigid and uh, yeah secure web applications, both web applications and Python applications generally. So that is that. So encouragement for implementing best practices and staying updated in security measurements. Well, I would say one big encouragement is trying not to get hacked, because you're probably seeing the fines on those companies that get hacked. That's a lot of money. So you save your company, you save your team a lot of money by implementing best practices and secure applications that are difficult to get hacked, because most of the times we believe that yeah, there's no way this can get hacked, and eventually something happens and a hacker finds 0 day, and yeah, it's done. So by focusing a lot on these best practices and securing our Python applications as much as possible, we ensure that we are not vulnerable to these events, these unfortunate events. So that is a very big encouragement, and also just to become better, that is a big encouragement too. So I have had an amazing time with you. I guess I could not cover probably as much as I wanted to cover, but I guess I would also see. Yeah, it's been an amazing time having this talk, and I really hope you had a lot to learn from and you enjoyed it as much as I did. Thank you so much. Remember, my name is Canadine. You can contact me on LinkedIn. And yeah, whatever it is, we can talk about it. Thank you so much, and goodbye.